Techalyzer here. Today we're gonna check out what happened to this guy. It's the old UPS I've been talking about, I think, in the past. Initially, I used it for the purpose it was built for, that is connected to my PC, until I figured out that the problem really wasn't with the mains voltage, but rather with a poorly designed computer power supply. Even though it was one of those very good looking one with black wires and everything, but really crappy quality. We do have problems with the mains voltage here, even worse than I did in the first place we lived in. The lights flicker all the time. There are power outages, but yet there's no problem with my computer. So combined with the fact that it has a fan that is very noisy, and I really don't like noisy fans humming in my ear all day long, I just stopped using it. Recently, I wanted to try and use it to power up a grinder because I'm solving some rust issues on my car. And living in an apartment building, I really don't have any other chance to bring any power tools to the car except for having an UPS or some kind of inverter. I don't have an inverter. And this really is annoying because it has two batteries in series, so it runs at 24 volts. If it ran at 12, I could have just connected it to the battery on my car and whatever. And no, I can't run an extension cord all the way to the car. It's not doable. Sometimes it is, but the parking space isn't right next to the building. There's a sidewalk, and it's really inconvenient. It would cross the path of many people, and it also has this contact that ensures that the battery is connected. But it doesn't even matter. I'm not gonna plug the batteries in because you see it's plugged in. This is the cable from the printer, so it's powered. It should start nonetheless with or without batteries, and it just doesn't do anything at all. And I had to manually cut some metal on my car, and I cut myself, and crap. I want to see what's going on inside. I'll just take the PCB off of it, and I'll come back to show you what went wrong. Now, my first advice, if you want to try and repair stuff like this, is always start with the simple stuff. Otherwise, if you go for the main idea is if you have something like this that's broken, don't go for testing the microcontroller first, like this guy right here or whatever that is, because it's very unlikely for that to be the issue. And if it is something like a blown fuse or a blown varistor or a wire that has been disconnected or pinched or stuff like that, you're gonna be spending hours, even an entire day, just looking for problems that don't exist. Of course, if the problem is more complex, you go ahead and deal with it. But in the start, I have learned that simple stuff like just a piece of wire that isn't making contact anymore is very worth checking before going ahead and do the complex stuff, because it can save a lot of precious time. That being said, I'm gonna start with the obvious, just to turn on my multimeter. Can I do something to include? Go ahead and test for continuity with the very beginning, which is the power wires. So this is the brown. I just wasn't touching the metal properly. And the blue one, I'm not sure how the microphone is gonna be. I keep hitting it with my chin. I might want to invest in a cheap microphone. So that's all good. Let's see the varistors. And it's an open line. And an open line. This one's the thermistor. I already checked the fuses. I was hoping it was gonna be a blown fuse for some reason. But here we go. This is one. And we have two more here. Car-like fuses, which are just fine. Two 40 amp fuses. I did the visual inspection. There's nothing obvious, like a blown transistor on anything. But the thing doesn't power on. So something around the power, maybe? I don't know. I don't have much experience with this. Please don't be offended by this. If you haven't, if you don't know this already, I'm not a professional electronist. This is not my job. It's just a hobby. I don't work with these things all day long, so yeah, my cat is playing. I don't really know where to start. I gotta keep visually inspecting this because, as I said, it has these add-on boards that can't be disconnected in any way. They are just soldered onto the cables, and that's a bit weird. On the back side, it's not really much to see. Also pay attention to solder joints. A lot of them can go bad. They can crack in time and cause all sorts of issues. There are a few that look a bit weird here, but there's the thing, you see, one example of something that can take hours out of your day. Come on, come on! I hate that. Okay, so there are these spots right here, and they look like some kind of liquid has gotten through into an area of contact with something that comes in contact with the PCB or something that it sits on, and it kind of looks like it's a bit corroded actually. And it might just be enough to short out these two tracks here and to prevent the thing from powering on. I don't have any kind of alcohol. I don't have any kind of cloth with me. But that's fine. This one's a lot worse. Look at that. Something weird in there that's not supposed to be in there. If that's the cause, just scraping it off like this will be enough. I did buy some isopropyl alcohol, but I used it to pour in my gas tank because we had some really low temperatures lately here, and at one point there was water that froze into my gas tank and I couldn't start a car anymore. So what you do is you put a bit of isopropyl alcohol, mostly recommended when you have low fuel and you don't have much fuel left, and that mixes with the water and it just goes and burns in the engine. I had these spots that seem to be a bit affected by some kind of liquid spillage. Oh, stop it! The only moments when he plays is when he shouldn't. Cats are dumb. I would really like to see if that did anything. Oh, it's gonna be difficult because I need these wires. To be connected to the... Oh, the battery's going, come on. Damn it. I would pretty much like to have two live wires right now rather than bringing the case over here. But here we go. Oh! Here we go. Oh, this is so dumb. Okay, I'm gonna have to come back. The battery is dying anyway. Okay, I have managed to plug that connector in. I'm gonna be careful now not to touch anything here, and let's see what happens. I'm gonna try to absolutely nothing. So I'll unplug it. It's been a while since I worked with live voltage. Let's see what else can be bad. Any capacitors I should be aware of. Ah, man, why don't they make... You know what, I'm gonna try this as well in case it's disabled by this, because it might be the case when that battery connection disables it. Nope. It's completely gone. It would power up just fine without batteries. It would just notify you that there's no battery or low battery. The thing is, I took out the buzzer from it. And I have no idea if it actually makes a sound or not. And I don't think I have the buzzer either. Now these guys would be the transistors used and diodes used in the inverter. So let me see, 5 and 1. So I don't think these are the issue. The issue should be somewhere around this area, I think. I have no idea. Since I was talking about the simple fixes, I want to just go ahead and check the connections for the buttons PCB, including the buttons. Yeah, this is gonna be a long one. So it's these two sides. No problem there. No problem there. Let's see the wires. This one's gonna go here. Weird construction, I tell you. Another one. Another one. Another one. Another one. One more. One more. And the last one. So the connection is fine. Oh boy, this is getting bad. It's getting bad really fast. Yeah, it's really hard to follow these PCBs. They have all these points that go through the board and make contacts back and forth through the layers, and it could in fact be connected to a microcontroller here, but I'm still what is this? U55. It's a 7805. Should I go for, that's a diode. I think I'm going for a bit of semiconductor measuring. That's a transistor here. Open. Open. There's 500 on this side. Wait, so 700. Okay, so 700. Okay, a diode. Let's see if we can get a better look. And also keeping the multimeter. What else? There's another transistor here. This one's gonna be and I have no idea how the power on signal works either. So I kind of want to see if I have 5 volts on that 7805, because I have the feeling it might actually be the power source for the microcontroller, which is very important. So I'm going to switch this to DC. Try to stay away from any high voltages. If this is a 7805, I think we are not gonna get like 1000 volts. It's really hard for me to see where I'm. That's 1 point. No. It's the zeroest zero you can see. Because there should be some power somewhere. Now let's see where exactly. Here. Maybe this line. The big capacitor. Sweaty palms, sweaty palms. What about these two? No. Earth, ground. We don't have any ground. One of these is gonna be the mains. Oh, I got it on DC. 14 volts. Okay. So I guess I'll be doing some more testing and then come back when I have something interesting, because this takes too long. And what do you know, sometimes a little bit of perseverance can solve the problem. This is a very good lesson of do not listen to my stupid brain issue. It's not the only time, and it's why I want so much to finish rebuilding. Anyway, I'm not going into detail. I had a PHP, a web app I built a while ago. I used it to generate invoices and kind of like a small CRM solution for my company while I had my company. And I kind of let it to rot after my company failed. And the idea is, and I still have the database, one of the sections of the app, which is how I actually began building it, and only after that I expanded it with the business options. It was a knowledge database at first, just like, say, I think Microsoft has. Though I'm not sure. Like, the Microsoft forums where they answer solutions, they answer questions and they mark solutions. It was basically a big, large table with first column the problem, the second problem the solution. Because just like in this case, there are numerous times when I work with something, I spend a day or two or multiple days or even weeks trying to figure out what goes wrong, I find out the solution. And it's very important, especially for these very complex things. And then I need to do the same thing a few years later, and I totally forget what everything was meant to be done. And that's why I built it. I really need to make it run again, because this was in my brain. It works without batteries. I don't know why. It was very real, so I didn't bother hooking the batteries and anything to it, because I know it started. I knew it started without the batteries, and obviously it didn't. So what I did, there was a small transistor, an SMD transistor on the back that I replaced. I actually replaced it with a normal transistor, but a smaller kind. You know, the ones that are a bit smaller than this one. Saying they're almost SMD size, so I think it, yeah, given the length of these spacers, it fits very nicely in there. And then this optocoupler here seemed to be a bit seemed to be not very okay. I tried testing it and it didn't seem to work, so I replaced it with just a random one I had, but I guess there's not much difference between them. Just an LED and a photo transistor, whatever. It's basically the same thing. And I resoldered immediately. Immediately after I said that. I think I said somewhere in the video that these contacts are okay. I just this button PCB went loose, and I was just holding it in my hands, and all the connections broke at the same time here. And yeah, as you can see, it works. I'm gonna prove it to you. I'm gonna power it up. It's not powered up right now, I think. It's just I think it's just charging the batteries. DC. I'm gonna do this one-handed. Just one battery, because we know somewhere around 14.4. Well, obviously not 14, it kind of rises in time. But if we keep the lead series, it's 1358. Now it's 59. It's gonna go to 59. And the batteries are quite low, if you ask me. So I'm gonna have to come back with you, but it is charging them, because they're at a level of like 12.5, 12.4, which is really low for a lead acid battery. It's partially discharged. Yeah, so always bear in mind that what you are absolutely certain of might not necessarily be true. I'm gonna just stop it, put everything back together and into its case, clean the stuff a bit. Now, there is the problem with the fan still left. Let's see if it gives an error. I think one of the red LEDs should light up. If I just stop the fan with my hand, because it has that yellow wire, which is an RPM sensor. Boom. Yep. And now it would beep if it still had the buzzer in there. It's constantly pushing against my hand. Just hear that noise. And you understand why I wanted it to be gone from this UPS, but and the only things that would require cooling are these heat sinks. Well, actually, this one gets a bit warm. I think this one charges the battery. But it's not going up to that point. Also, don't do this. If I were to touch some ground or other metal parts with another thing there, on my other hand, I would get a shock, because these are usually live. It even has a caution label on it. But the thing is, it doesn't get to that point where it would need a fan. It's just warm. It's normal for a heatsink to be warm. It means it's working. I don't know. Anyway, for what I needed it, it's fine to have the fan noise as well. Maybe I can get it out, because I still need some work to be done on my car, and I would really appreciate it if I could use this one. I have no idea what's going on here. Wasn't it a different value? It was 48, it's 49 now. I think it's only charging when it's powered on, to be honest. So it's 1349. We should be able to see a 1350. It's absolutely deafening, especially at this time at 9 p.m. Who came up with this? Nope, still just barely even warm. It's like somewhere around maybe 40 Celsius. Just a little bit warmer than the human body. That one's cold. It's probably not doing anything. I hope this cable is okay, because I didn't have the connecting cable between the batteries, and I improvised. It's not as thick as these ones, but it worked. No, I don't have any idea what's going on with the voltage for the batteries. I'm gonna have to let it run. And being with a microcontroller, and by the way, that's a Motorola microcontroller, it might have, like the advanced kind of algorithm for charging the batteries. Maybe it it pulses them every few seconds, or I'm not very familiar with the advanced charging techniques, so that might be what's going on. thus it might take some time until the voltage goes up. So I'm gonna put it back together, let it run for a while, and come back with the results and see if it charges the batteries. And sure enough, and I'm just gonna put it aside, let it run for a while and see if it charges the battery properly, but there is no reason why it shouldn't. I let it run for a few hours. I'm now in the kitchen because I brought it here because it makes this unbearable noise from that fan. We're set to DC, and as we can see, when it was 13.2, now it slowly drops, but these were like at 12.4, maybe 12.3, and anything above 12.6 is 100% charged for a lead acid battery. So yeah, 12.99 is okay. It's gonna continue dropping for a while now. I'm just recording this to show you that indeed the battery charging is working. I think I'm gonna leave it overnight just to be sure that the batteries are in the best condition that they can be in. So that's it. We learned something new today. Okay, so it's the moment of truth now. I let this UPS run for, well, not the entire night, but for a considerable amount of hours, because it was around 11 or 12 p.m. I think, and I went to sleep at 4:30 a.m. So yeah, and then I turned it off right before going to sleep because, as I mentioned a couple of times, it's incredibly loud due to that messed up fan, and I'm sleeping right behind this wall here, so I don't really like have sounds like that while I'm sleeping, especially when I know I'm not sleeping too much. It's been a couple of hours since I also disconnected the batteries from the UPS so that they're really at their standby voltage, and we're now gonna see what kind of voltage we get. Kind of hard to do with one hand, but luckily there are these holes that I can put my probes into. 1306, that is definitely perfectly charged. Remember, 100% is 12.6, so anything above 13 or around 13, this one as well. Two perfectly fine batteries. And now for the actual test, for what I wanted to use this thing for. This is gonna be interesting. I want to see if I can power this grinder. I gotta connect them first. In goes the negative. Gotta plug it in. This extension cord was actually made by me precisely so it can go behind here into the UPS output. And let's see, power up. No? Oh, because oh yeah, that's a problem. I'm gonna need to actually put the battery back in. This these contacts here that connect the battery to the board, and you have to push it in place. Now let's see. Power on. Let's wait until okay, it's on battery now. And let's see. Oh, it wasn't plugged in. And it's plugged into itself. Wow. Absolutely fantastic. I honestly didn't think it will work. I know that there's a problem with electric motors like these, but it's been a long time. I think they need a pure sine wave or something. If it's squared sine, I think there's some heating issues, or maybe it doesn't spin as fast as I don't know exactly what problem it was, but I remember it wasn't good for electric motors. But as we have seen the PCB, this thing seems to be quite a high quality thing. I mean, it's not one of those $50 brand new UPS. It's something a little more than that. I don't know for how long it keeps this running, but you know, it doesn't have to be too long. Like if you need to cut a little square in one of the body panels on the car, as I need to, you probably need like a total working time of like 1 minute. And the metal sheet is also very, very thin on my car. So actually the place where I have the rust holes actually has a metal sheet that is thinner than this metal case that the UPS has. So this will go straight through. It would go like a knife through butter. Some words are difficult to pronounce in English. Butter. Yeah, it's weird, you know, sometimes. Whoop, still connected. I don't wear much protective gear. I even took that metal guard off because it actually interferes with what I need to do with it.